This is the video for Lesson 5-2, Adding and Subtracting Like Fractions. Fractions that have the same denominators are called like fractions. And we really like fractions because we don't have to do a whole lot of work here. It says to add or subtract like fractions, we're going to add or subtract the numerators and write the result over the denominator and then simplify. So some examples. 1/5 plus 3/5. We add our 1 plus 3 to get 4, and our fifths stay the same. 11/12 minus 7/12 is 4/12 because 11 minus 7 is 4. We keep the same denominator. However, 4/12 we need to simplify, so we divide out 4 from the numerator and the denominator, and we get 1/3. If we are going to write this in algebra, well, a over c plus b over c, we're going to add our two numerators, so we get a plus b, and we keep it over c. A over c minus b over c, we're going to subtract our numerators, so a minus b, over c. So let's get right to doing some examples. We're going to, once again, add the numerators, keep the same denominator, and then write in simplest form. So 5/9 plus 2/9, I'm going to write in this extra step. You don't need to, but I'm going to say 5 plus 2 over 9, and 5 plus 2 is 7/9. And that's simplified, so that is our answer. You'll find that this middle step might be helpful, especially when we throw in some negative numbers. Okay, but you don't have to do this 5 plus 2 over 9. I know most of us can probably jump right to the 7/9. 7/10 plus 1/10. We're going to say 7 plus 1 over 10, which is 8/10. And we can simplify that, so we divide out a 2, we get 4/5. Okay, to subtract. Okay, we're going to apply our integer rules now also. And you'll notice I put this in bold letters. It says when adding or subtracting fractions with negatives, it's best to place the negative with the numerator. So in -4/7, okay, remember we can put the negative on the outside of the fraction bar, we can stick it with the numerator, or we could stick it with the denominator. I'm telling you that it's best to stick it with the numerator. So we're going to say -4. We're subtracting, so we're going to minus 2, and that should still be over 7. Well, -4 minus 2, use our integer rules, would be -4 plus a -2, and that gives us -6/7. Once again, your negative can be on the outside of the fraction bar, up with the 6 in the numerator, or down in the denominator with the 7. All three would be the same answer. In letter B, I see minus a negative. So we're going to change that, okay, to adding the opposite. So it becomes plus 3/10. Your two minus signs become a plus. Now we can add our numerators together, keep our original denominator, and we get 4/10. But we divide both by 2, we end up with 2/5. Okay, so I want you to give a try with the 4 questions at the bottom of the first page. Okay, so pause the video, and when you're ready to go, press play again to see how you did. Okay, for number 1, we're adding 3 and 2 in the numerator, keeping the denominator of 8. So our final answer is 5/8. In number 2, it's best to stick the negative with the 1. So we're going to say -1 plus 5 over 6. -1 plus 5 gives you 4, so 4/6, which simplifies to 2/3. We have 2 minus 7 over 15, but that's not your typical subtraction, so we're going to say 2 plus a -7, which means -5/15. And if we simplify that, we get -1/3. And finally, we have the minus the negative, so I'm going to rewrite it as 1/12 adding the opposite of negative 7/12, which is a positive 7/12. We get 1 plus 7 over 12, which is 8/12. And if we divide out 4, we get 2/3. Okay, let's flip the paper over. Let's try to add and subtract mixed numbers. Now I'm going to give you two different methods for working with mixed numbers. You can choose whichever way you prefer. However, I'm going to keep showing both methods so that we can check our answers both ways. Method 1 is to change your mixed numbers to improper fractions. So we have 5 and 5/9. The whole number times the denominator, so 5 times 9 is 45, plus the 5, so you get 50 over 9. And then 2 times 9 is 18, plus the 7 is 25, so we get 25/9. Okay, so we have the same denominator, which is great, so we can just add our numerators together. So we get 75/9. However, we don't want to leave it as an improper fraction. We need to change it back to a mixed number. So we're going to say, how many times does 9 go into 75? Well, that would be 8. So 8 is our whole number. 8 times 9 is 72, which means there were 3 left over. So we get 8 3/9. And our final answer, because that's not quite simplified, is 8 1/3. Okay, method 2. Method 2, we're going to split up the whole number and the fraction. Okay, I use the format where I have 2 parentheses, a plus sign, and then another set of parentheses. I'm going to say that this is always addition. Okay, you might want to write that down in case this is the method you want to do. Always addition in between your 2 sets of parentheses. So we're going to take 5 and 5/9, and we're going to say, let's put the 5 there and the 5/9 over there. So we're splitting up our whole numbers from our fractions. The 2 and 7/9, we're going to say, put the 2 there and the 7/9 in the second set. Now what goes in between here is determined by what operation we have. We have addition, so we're adding those two things together. Okay, so we're going to do 5 plus 2 to get 7. Over here, we bring down our plus. 5/9 plus 7/9 is 12/9. Okay. Let's change this to a mixed number. So 7 plus, that would be 1 3/9. Okay. 7 plus 1 is 8. So we get 8 3/9 because we can add our whole numbers together here. And then our final step is to simplify the 3/9, so we get 8 1/3. Okay, you'll notice it's the same answer we got before. Let's try B. We're going to change them into improper fractions for our first method. Okay, remember, ignore that negative for now. Change 10 and 6/13 to an improper fraction and throw the negative back on. So 10 times 13 is 130, plus 6 is 136, and it's negative, minus 6 times 13. Let's see on the side. 3 times 6 is 18, 6 times 1 is 6, plus 1 is 78. Add in your 8 from the numerator, we get 86. So we're going to subtract 86/13. And I'm going to rewrite this, okay, with that extra step I mentioned before. So negative 136 minus 86, I'm subtracting the numerators, over 13. Well, here we can change this to adding the negative. So really, we're adding our two numbers together. 6 plus 6 is 12. 1 plus 3 is 4. 4 plus 8 is 12. And 1 plus 1 is 2. So we get negative 222 divided by over 13. And now we need to change this into a mixed number, and I need a little bit more room here. So we're going to say 222 divided by 13. Well, 13 goes into 22 one time. Okay, we get a remainder of 9. Bring down the 2. 13 goes into that. Let's try 5. 5 times 3 is 15. 5 times 1, oop, too small. Okay, that's fine. How about 7? 7 times 3 is 21. 7 times 1 is 7 plus 2 is 9. So we have a remainder of 1. So the way we work this out is we take our quotient, that's our whole number, so negative 17. We have a remainder of 1, so that's our numerator. And our denominator is 13. So negative 17 and 1/13. That one was a little bit of work. Let's try it with the other method. Okay, I'm going to create my parentheses. Oops, need to put a plus in the middle. Always a plus. So now, when I split up my negative 10 and 6/13, I need to remember that this negative applies to both the whole number and the fraction. So it's going to be negative 10, but I'm also going to write negative 6/13. Okay, we're subtracting. So subtract 6 on this side, and then we're going to subtract 8/13 on the other side. So negative 10 minus 6 plus a negative, that gives you negative 16. And over here, this is like plus a negative, this gives you negative 14/13. Well, negative 16 plus, bring it down. And then this here is going to be negative 1 and 1/13. And if we add them together, same sign, so we add our numbers, which means we can add the number parts together. So we get negative 17 and 1/13. So this way, while it seems a little trickier, was actually less work than doing it the improper fraction way. Okay, so you might use the method 1 for some problems, and then method 2 for some others. Okay, when you get to this step, you just have to be careful. If we have a negative and a positive, okay, that does kind of change the way we combine our numbers. You'd have to use your integer rules there and be careful. Okay. How about you try the 2 checkpoint questions? Okay, so pause the video, and when you're done, press play again. Okay, if we did method 1, we would do 6 times 3 is 18, plus 2 is 20, so negative 20 over 3. 3 times 3 is 9, plus 1 is 10, so 10 over 3. Okay, this would be negative 20 plus 10 over 3. That's negative 10/3, which would be negative 3 1/3. If we did it the other way, we'd have negative 6 and also negative 2/3. Oops. And we're adding 3 and adding a third. So our first parenthesis gives us negative 3. Negative 2/3 plus 1/3. Negative 2 plus 1 is negative 1. So we get negative 3 plus negative 1/3. And since they're both negatives, we can squish them together. We get negative 3 1/3. For number 6, improper fraction way, 3 times 7 is 21, plus 2 is 23, so negative 23/7. 6 times 7 is 42, plus 3 is 45, so minus 45 sevenths. This is negative 23 minus 45 over 7. That's plus a negative. So we get negative 68 over 7. 7 would go into that 9 times, so negative 9. That would be 63. So negative 9 and 5 sevenths. Splitting it up, be negative 3 and negative 2 sevenths. Remember, plus always goes in the middle. We are subtracting 6, subtracting 3 sevenths. So over here, plus a negative, we get negative 9. Negative 2 sevenths minus 3 sevenths would be the same thing as adding a negative. So we get negative 5 sevenths. Since we have a negative whole number and a negative fraction, we can just squish them together. Final example, simplifying variable expressions. Now, just because we're throwing in some variables does not mean you need to freak out. Okay, same steps as before. So letter A, we have 3a over 20 plus 5a over 20. Okay, if we write in that middle step, we're going to add our numerators together. We're going to keep our original denominator. And we know how to do this. This is just combining our like terms. If we have 3a's and we add 5a's, we get 8a's over 20. However, this is not simplified. Remember, if you have variables in your numerator and your denominator, that's not simplified. And if you have numbers in your numerator and your denominator, where something goes into both of them, you need to keep going. So here, we can divide out a 4. So 8 divided by 4 is 2, and we still have that a. And 20 divided by 4 is 5. So our answer is 2a over 5. In letter B, I see that minus a negative, and we don't like that. So I'm going to change it to adding 2 over 3b. We have a common denominator of 3b. So we're going to say negative 8 plus 2 over 3b. Negative 8 plus 2 is a negative 6 over 3b. And I need to simplify this. Okay, so we'll say if we take out a 2, this would make, sorry, not take out a 2, take out a 3. Negative 6 divided by 3 is negative 2. 3 divided by 3 is 1. So we get negative 2 over b. And that's our answer. Notice the b doesn't go anywhere. It stays on the bottom. Okay? If you have any questions, please make sure you wrote them down. Okay? You might want to go on to the e-workbook to try and do some practice problems. And we will work on this tomorrow.